Ladies and gentlemen, thank you very much for giving me voice. Today I will be talking about article published in waste management in 2023 under leadership of Czech University of Life Science. The work is between Elizaveta Czernysz, Victoria Czabur, and Hinek Lubik. And it's entitled Environmental Aspects of Biogas Production. Globally, there is an increasing awareness that renewable energy and energy efficiency are vital to creating new economic opportunities and controlling environmental pollution. And it should be kept in mind that environmental pollution and energy insecurity are among the key challenges in the 20th century. Furthermore, the mitigation of carbon dioxide emissions and related global warming requires the exploration of alternative energy in order to reduce the dependency of fossil fuels. One of the options is the transformation of organic waste through anaerobic digestion into biogas. Biogas produced via the anaerobic digestion of organic waste is considered an important technology in improving the environment because it solves waste management problems and simultaneously produces biogas as a main product and digested as a byproduct, which can also be used as fertilizer. The utilization of AD represents an appropriate solution to health, hygiene, and environmental problems. Biogas production through the anaerobic digestion process provides significant advantages over forms of renewable energy. It has been demonstrated to be one of the most energy environment efficient and environmentally friendly forms of energy and of technologies for renewable energy production. And although the conversion of waste to biogas is an established technology, it has still been underused and has not reached a full potential. Therefore, here show how in Czech Republic could develop. The production of biohydrogen and biomethane from waste is currently major focus in world. Biogas and biomethane can potentially reduce carbon dioxide emission and is the one of green energy trends, and European Union pay great attention to this direction, and a powerful project cluster funded by international grant systems are formed, and European Union Energy is Bioeconomy Development Strategy until 2030, Bioeconomy to 2030, designing a policy and the agenda. European Union seeks to shift circularity and sustainable from substitution. Biogas production is important technology in the sustainable use of organic waste as a resource for the production of renewable energy. For the last 20 years, interest in the topic has increased significantly. According to the Scopus that the previous 5 years, 80 to 100 per year had been noticed. The new Web of Science has shown noticeable interest since 2015. The number of websites publications has exponentially grown since 2017 to 120, 170. However, was decreased in the COVID time and then afterwards, Ukrainian war also. So these were increasing, and mostly USA, Brazil, and Sweden have a big potential as also Poland. The share of greenhouse gas emission for agriculture is currently approximately 13%, a substantial percentage of the total. Agriculture emissions are expected to increase along with the growing demand for food fuel, fiber, and other materials supplied by agriculture. At the same time, the new technologies and agriculture practices are interconnected with the responsibility to reduce greenhouse gas emissions from the agriculture sector. This methane is and nitrogen oxide and carbon dioxide is a digestive fermentation in livestock manure management, is the rice farming burning of leaf residues, land use conversions to photosynthesis, is digestive fermentation in livestock, so practices burning of yields residues, energy consumption on the farm, burning of fuel, urea application and soil liming, crop cover crop conversion of the farming and biochar, which goes to soil and improvement soil. The group of lister's, which is produce large amount of methane, is precisely during conversion of carbohydrates or by feed of ruminants, which is lignosulfurous feed, and second branch is cultivation of rice and food waste. At the same time, rice grown in the mountains doesn't significantly amounts of methane. Furthermore, the recommended burning of savanna occurs every 1 to 4 years. Burning of savannas produce emissions of carbon dioxide, carbon monoxide, methane, and nitrogen oxides. The flow of carbon and nitrogen in the ecosystem can be managed in several ways. Can be promoted by sufficient crops, livestock diets of nutrients, water management in rice and other cultivation can be improved to improve carbon sequestration. Other technology converts carbon dioxide into other technologies as a methanol organic substance. Various technologies are used to reduce greenhouse gas emissions. In addition to the fact that agricultural waste enable digestion, plants offer the possibility to avoid emissions from animal waste storage. They also provide the possibility of obtaining renewable energy with negative carbon emissions with biogas. It is necessary to consider methane emissions in the context of the balance of greenhouse gases and overall sustainability of the bioenergy system, as there is a risk of methane emissions from biogas system and the application of the necessary safety measures to prevent leakage. Is benefit reference in benefit, especially reducing the consumption of policy and benefits extended fossil depletion period, obtaining a practical accessible source of energy, which is biomass, is constantly reviewed, no carbon footprint, climate protection, reducing the amount of waste and the volume of accumulation, which reduces pollution of the environment, reduction of local pollution with lower amount of harmful emissions, safety, environment, shortening time of disposal of animal waste, reduction of organic substances in waste and wastewater, closing the cycle of nutrient by biogas production, and ecological closure, reduction of in areas located for waste and additional use of agricultural land, application of digested starch, improve soil, solving a number of the hygiene tasks, moving technology source. For example, one of the most large tonnage war organic waste belongs to the category of unstable organic contaminants and transmission more than 100 species of various pathogens and animal and human diseases. Biogas is characterized by a high content of environmentally hazardous substances, ammonia, hydrogen sulfide, phenol heavy metals at the level of chemicals pollution is the environmental 10 times more dangerous compared to the municipal solid waste. In the form of flowchart, the figure compares with the greenhouse emissions from conventional manual storage and anaerobic digestion according to Packer and Valley. The more detailed ecology are complexes is going digested is emissions of methane if conversion in the soil. And if we methane, we already reduce by conversion, go to conversion of carbon dioxide by possible plant or by upgrading and soil storage. This is the solving implementation of biogas to process animal waste, make ponds for buildings that be stored in ponds for 6 months in the case of diaphragms or 12 in case of pig farms. The major source of airborne pollutants and can be soil and groundwater stacks, and storage facilities also occupy large areas. Biogas protect chains can either reduce waste storage areas to eliminate such manure and manure storage by supplying them immediately. Organic waste from livestock, such as and the processing industry itself is already a fertilizer. When the waste is processed via biogas plant, its property are significantly improved. There are 37,000 a year, gives approximately 35,000 tons. 1 ton of advantage is pumped organic fertilizer, manure, dung peat. Big manure, cattle manure, and peat manure usually contain mainly wheat seeds. The fertilizer is the absence of adaptation period. Manure and other organic matter require long preparation before application to the soil. Furthermore, it should be noted that organic on the method and duration of storage, even greater losses are observed during freezing and with subsequent throwing up. Therefore, you not only have imperable emissions reduction will be achieved by sources. 5 to 10 by 15%, 600. Mass shouldn't exceed 0.50 megapascals. And use of ecological method preparation, monitoring method tanks, enclosure, high quality safe fertilizer, biogas potential capture of greenhouse gases, sanitation of waste, environmental benefits of green hydrogen, water vapor is not formed, not carbon dioxide is released, 30 to 40 higher efficiency compared to traditional hydrocarbons, possibility of universal use, possibility of short and long-term storage is the challenge here. The environmental friendly field gives structure, farm, compost solvents, they can recycle the phosphorus and salts as nitrogen and potassium. This homogenization, acetogenic fermentation gives rich methane, and biogas generation purification for hydrosulfide, and this gives lab assessment technology. Lab assessment is closer, and the very big livestock waste treatment of China, large domestic biogas plants show good environmental sustainable in terms of reducing pollutants, emissions, and producing clean energy. Similarly, comparing to microalgae, summarizing the biogas processes, it is determined that algae more than 70% of the consumption is the demand in fertilizer production and 50% of total emissions. The pretreatment anaerobic system is determined to be more feasible and environmentally safe among unjust bioenergy conversion system. This energy system has polymers and acids and as well fertilizer. On the contrary, domestic plants show greater potential for acidification, eutrophication, and human toxicity, mainly due to increased sulfate and ammonia emission. The high environmental impact potential is related to biogas production and digested in different scale biogas plants. Life cycle impacts, the greenhouse and carbon dioxide from the plant contributed to a significant reduction. The assessment of the life cycle of biogas plant technologies is still strategically important for the technical development of renewable energy and waste management. At the same time, several studies modify the methodological approach to the life cycle assessment with different measurement values for parametric variables. Based on that, number of studies analyze the life cycle assessment of biogas production of given origin substrate, and this is biogas, digester, biofertilizer, and household. These Gawel emissions was methane, carbon monoxide, ammonia, livestock feed production transportation, reduce airborne emissions at global warming potential, airborne emissions, carbon dioxide, methane, monoxide, waterborne emission, ammonia, airborne emissions, wasteborne emissions to soil, ammonia, potassium, phosphorus. Treated under anaerobic digestion can supply electricity consumption and produce a biofertilizer with ammonia content. Efficiency can be achieved by using a digestate as a fertilizer, avoiding the impact of minerals fertilizers. The environmental efficiency of the higher biogas is options higher. So processing industry is mining requiring waste collected from household is 1.3, 1.2 is agriculture, forestry, and fisheries, power, steam, gas supply, and other activities. There's gone child with cultivation, residues, and today much attention is paid to the search for sustainable methods of recycling. Waste management is the main type of animal waste treatment. This method eliminates twice as much as production of waste and mixed food products. Incineration is the most common method of handling plant waste, which means that 434 tons of energy were banned in 2020. Hula farms are very popular war in Ukraine, but now is due to war is very hard to make. In conclusion, important side of biogas production is the use of biogas production in the renewable energy sources, which are waste at the same time. The use of organic waste creates an ecological effect on transportation, storage, and use. The ecological effect of biogas plant is environmentally safe processing of organic waste byproducts through anaerobic digestion. The agro-industrial industry is one of the largest sources of supply of methane and other greenhouse gases utilization method by biogas production can be reduced and used in correct way. Production of electricity on the combustion biogas units is a solution to the issues of energy dependence and enterprise. A significant aspect is that fermentation residues from biogas production in the biogas plants are quality fertilizer that can be sold and used instead of mineral fertilizer. So that's all. Thank you very much for listening to me.